Here we have another example of an amortized loan. It's a 15-year mortgage for $150,000 and the interest rate is 0.75% per month. Monthly payments are $1,521. The question asks how much principal amount is left to be repaid after the first two payments. Well, again, let us look how this loan is amortized through time. Your beginning principal is $150,000. The interest for the first month is going to be the beginning principal multiplied by the interest rate, and 0.75% is going to be equal to 0.0075. So the interest amount is going to be $1,125. So here the periods are a month in length because each payment comes in after a month. So interest is calculated for every month. The principal reduction is going to be the amount of payment, which is $1,521.40 minus the amount of interest. So that is going to be $396.40. The ending principal will be the starting principal minus principal reduction, and that will equal $149,603.60. So this was the starting principal, this was the interest payment, this was the total payment. Total payment minus interest payment was principal reduction, and ending principal was initial principal minus principal reduction, which will give you the ending principal. For the second month, we begin with a principal of $149,603.60. We calculate the interest by multiplying it by 0.0075. So the interest is $1,122.03. The principal reduction is going to be the amount paid minus the interest payment, and that equals $399.37. So what you're seeing with these kind of amortized loans also is that with time, the amount of interest is falling because the principal is reducing. And when the amount of interest falls, because the payments are constant, it means that the principal reduction keeps increasing as we move forward. So here, for the second month, the principal reduction was $399.37, which would have been greater than the principal reduction for the first month, which was about $396.40. The ending principal is going to be the initial principal minus principal reduction, or that is $149,204.23. So this is going to be your remaining principal after the second payment has been made. Now, what happens, of course, in reality is that when people repay their loans, it's not generally after 2 months. It could be after they've lived in a house for 5 years or 10 years. So it's going to be much more number of months. And if you have 5 years, then you have to do this thing to get to the 60th month. And that's going to be like really tedious. So we're going to look at some other way to answer this question. So the second way to answer this question is going to be, we will instead look at the remaining payments to be made and find the present value of that. So what we are going to have is, we have a timeline, and in this timeline, every month, there is a payment of $1,521.40, and it was a 15-year mortgage, so that means there were 180 months total. Now, where did this $1,521 21.40 come? Well, this is the amount which pays off the loan, which also means that the loan of 150,000 would equal 1521.40 divided by 0.0075 into 1 minus 1.0075 to the power 180. You can check for yourself if this is correct. Now, if I was to use a different method to find the answer to how much principal remains, what I would do is I would say, okay, I've made this payment, I've made this payment. Now there are 178 payments left. Also each of amount 1521.40. So what is the present value at this time of these 178 payments left? And that would be the outstanding principal. Okay. So these remaining 178 payments would pay off that outstanding principal. So that should equal 1521.40 divided by 0.0075 into 1 minus 1 upon 1.0075 to the power 178. And if you calculate this, you are going to get 149,204, which is the same as you got by this other method. And again, it's really the equivalence of moving ahead in time or moving back in time. If you're using the same rate, it does not really matter which one you do, both will give you the same answer. So the way to find remaining principal is just to find the value of the remaining payments to be made at the point in time where you're trying to find the value of the remaining principal. And this, of course, it's easy to do, let's say, if there are 120 payments remaining after you made 60 payments, etc. So this you don't have to do it like for every month. This is just one formula which you can calculate. So in this question, we again have an annuity, and now it's a 30-year mortgage. The amount borrowed is 200,000, and the interest rate is 5%, 0.5% monthly. And the question first asks you, what are the monthly payments which have to be made to pay off this loan? And secondly, how much principal is left to be repaid after the first 60 monthly payments? So to find the monthly payments, you use the annuity formula. You set the borrowed amount 200,000. The K stands for kilo, which is short for 1,000. So you have 200,000 equals the cash flow that you'll be paying monthly, C divided by the interest rate, that is 0.005, into 1 minus 1 plus the interest rate to the power n, and n is 360. So you use this formula to solve for C, and you get C2 equal 1,199 and 10 cents. So that's the monthly repayment which would pay off this mortgage. The second part of the question is, how much money would be left to be repaid after 60 payments have been made? And again, think of a timeline. This is today, and then 60 payments have been made. The total number of payments was supposed to be 360. So that means 300 payments are left to be made. And the way to find the remaining principal at this point in time, after 60 payments have been made, is to find the present value of these 300 payments. So you use that in the formula. You divide the monthly payment, $11.99, divided by the rate of interest into 1 minus 1 divided by 1.005 to the power 300, and you get the answer to be 186,108.71. So one of the things which is kind of a bit disheartening, you may think, that is that this mortgage is being paid off very slowly. After 5 years, the mortgage value has fallen only from, outstanding principal has fallen only from 200,000 to 186,000. And the reason for that is, in the initial stages of a mortgage, most of the money goes to paying interest. And it's only after the principal has fallen that the amount of interest reduces and the repayment of the outstanding principal becomes faster. Here we have a little twist on the usual mortgage question. We have two balloon payments of 20,000 after 10 years and 30,000 after 20 years. So the question says, what is the monthly payment the borrower would have to make if, in addition to those monthly payments, the borrower also makes two balloon payments, repayments of 20,000 after 10 years and 30,000 after 20 years. Well, the way you answer this question is you say, okay, I have this mortgage amount, I have this borrowed amount, and first what I'm going to do is I'm going to find what the present value of these balloon payments are, and the present value of this 20,000 balloon payment is, if the monthly interest rate is 0.4%, then it is going to be 20,000 divided by 1.004. Now, 20 years, first we have 10 years. So 10 years is 120 months. So it will be to the power 120. So that's the present value of this first balloon payment. And that is going to be equal to 12,387.52. The present value of the $30,000 balloon payment, which is made after 20 years, is going to be 30,000 divided by 1.004 to the power 240. And that will equal 11,508.80. So we have these two balloon payments which have these present values. So think of now the borrowing as being repaid by these two balloon payments plus the annuity, which is going to be the mortgage repayments which the borrower makes. So we are going to subtract these two from the current borrowing of $300,000. So from $300,000 you subtract this and you subtract this, and what you get is $276,000, 103.68. So this is the amount which has to be repaid by the annuity, the monthly repayments which the borrower is going to make. And then to find that what the monthly repayment is going to be, we stick in the annuity formula. So we say this will equal, if the monthly repayment is C divided by 0.004 into 1 minus 1.004 to the power 360. Why 360? Because it's a 30-year loan and there are 360 months in 30 years. I should have mentioned over here that this was a 30-year loan. And you solve this, you have all the numbers, and the only thing you don't know is C, and it'll give you C equals 1,448 and 62. So that will be the monthly payment which will pay off this loan in addition to the 2 balloon payments. Here we have a car priced at $16,164, and the monthly repayments are $399.99 for 60 months, so that's a 5-year loan. And the question asks, what is the monthly interest rate being charged? And here you actually have to plug in the different interest rates into the formula to find the answer, because you can't algebraically solve for it. And of course, if you have your financial calculator, you just use the financial calculator, and it'll do all that work for you. But anyway, so the formula, what you're going to see is that this is going to be the right answer, 1.4%, and when you use 1.4%, then your annuity formula becomes the monthly repayment divided by the interest rate into 1 minus 1 plus the interest rate to the power n, and then here is 60. And this amount you will see actually does equal 16,164 and 37 cents. What is the APR quoted by the car dealer? Well, really the yearly interest rate would be 1.014 to the power 12, because these are 12 periods, so that's going to be the rate at which the money is growing going forward. However, the car dealers actually do the simple thing. They just take, instead of this, they simply take 1.4% and multiply it by 12, instead of taking to the power of 12 and adding 1. And that they'll report as 16.8%. So that's the APR which is reported, and that is actually a bit less than the actual rate, which would be found by 1.014 to the power 12 minus 1. You can confirm that this is actually going to be a bit more than 16.8%. To end the session, we are going to do a few practice questions. The first one is $1,000, which has been deposited in a bank account, and the yearly interest rate is 3%. The question is, how much does the depositor have after 15 years? So it's going to be 1,000 multiplied by 1 plus 3%. So that's 0.03 to the power n, the number of periods, which is 15. And that will equal 1,557 and 97 cents. Here we have some uneven rates of growth. In the first question, a firm's profits will grow at 15% for the first 5 years, followed by declines of 6% for 2 years. The question is, what is the total growth over these 7 years? So total growth is going to be the growth over the first 5 years multiplied by the decline in the next 2 years, and that is can be found as 1 plus 0.15 to the power 5 into 1, and now this is a drop of 6%, so it's actually negative. So it'll be minus 0.006 to the power 2. So this is 1.15 to the power 5 into 0.94 to the power 2, and if you work it out, it's going to be 1.7772, or the percentage growth is going to be 77.72%. In the next question, a firm's sales grow at a rate of 7% for 5 years, 4% for 3 years, and then 2% for 2 years. And the question asks, what is the total growth over the 10 years? So here you're going to have 1 plus 0.07 to the power 5 multiplied by 1 plus 0.04 to the power 3 into 1 plus 0.02 to the power 2. And when you work this out, you get 1.6414, or the percentage growth is 64.14%. If you are using the financial calculator, let's say the BA2, to find this, you would have to use the memory storage. So what you would do is you would do 1.07, and then you would press y to the power x, and then 5, and that will make it equal to, and this you want to store in the memory, so you do store 1, so it's stored in the first memory register. Then you next find 1.04 to the power 3, and that equals 1.1248, and that you store in the second register, and then you find 1.02 to the power 2, now this number you multiply by the two numbers stored in the two memory registers. So you multiply it by recall 1, multiply by recall 2, and you get 1.64142. Here we have a different take on the usual growth problem. Here you have to calculate the number of periods instead of generally calculate what the final value is. So a firm currently has sales of 1 million and a steady rate of growth of 7% a year. And the question is, how many years before it reaches 3 million? Well, if you write out the formula, it's going to be 1 multiplied by 1.07 to the power n equals 3. And how do you find n from such an equation? Well, what you do is you take the logs of both sides. So you're going to have then n log 1.07 equal to log 3, or which will give us n equal to log 3 divided by log 1.07, and this you can find using the log function in your calculator. It's there in generally all calculators, including your financial calculator, and this is going to turn out to equal 16.23757, or so it'll take a bit more than 16 years for it to reach sales of 3 million. In this question, it's a straight up mortgage question. You have a loan of $350,000 and it's a 30-year mortgage. Your mortgage rate is 3.6%, and this is the APR. So the actual rate will be 3.6% divided by 12, which is 0.3% monthly. And you have to find your monthly payments. So if your monthly payments are, let's say, C, then the formula would be 350,000 equals C divided by the monthly rate of interest, which is 0.003. So that's 0.3%. Into 1 minus 1.003 to the power number of periods, and the number of periods is 360. So when you solve it, you will get the monthly payments to equal, C would be equal to 1,591 and 26 cents. Here we have a question about purchasing a car, and there are two options. The first one has cashback, and the second one is a lower rate of financing. Now, there's a similar problem in a Wiley test bank or question bank or something, and what they do is they essentially find the future values, and the rates which they use are incorrect. So don't follow that, rather pay attention to this. So here what we have is, the first one is a cashback of 3,000. So assume that you can actually use the cashback to pay for part of the car price. So you owe 27,000 because the car price is 3,000. So you take out 3,000 cashback. So you owe 27,000. So basically you're financing 27,000 at 6% per annum for 5 years. Now you have a annuity, and in your financial calculator you can enter n equal to 60, I by y equal to, now it is finance at 1.6% for 5 years, so I by y will be 0.5% monthly. So you enter I by y equal to 0.5. Present value you'll enter as 27,000, and then you press compute, and then you press payment, and the payment will turn out to be minus 522.25. In the second one, you have a lower interest rate but no cashback. So you say that the entire cash has to be paid. So present value should be 30,000 rather than 27,000. And your interest rate, though, is now going to be 1.5 divided by 12, or that's going to be 0.125. So those are the only changes. This is going to be 0.125, and the present value is going to be 30,000. Your n is going to remain the same, and then again you do this compute and then payment, and the payment will turn out to be 519.60. So the second option is actually the better option, because you're comparing monthly payments, and you can see that this monthly payment is smaller than this monthly payment. Here we have a question where a father is trying to decide how much to deposit to pay for his son's future education. And so James wants to deposit a fixed amount every year for the next 8 years. And the college currently costs $20,000 a year, but is going to grow at, the cost of college is going to grow at 10% per annum. And the son will be in college for 4 years, so there will be 4 years of tuition which will need to be paid. 4 years of college expenses which will need to be paid, and the college is going to begin in 8 years' time, and the rate of return which James can earn on his deposits is 8%. So the question is, how much does James have to deposit every year? So the first thing that you calculate is how much is college going to cost the first year when the son begins college, and that is going to be the current cost of 20,000 multiplied by 1.1 because it's growing at an inflation rate of 10%. So 1.1 to the power 8. And that, when you calculate, it turns out to be 42,871. So that is going to be the cost of the first year of college, and it's a 4-year expense, so it's like a 4-year annuity. And when we have that annuity, it is going to grow at 10% every year, and we need to be able to provide for that. Now, just assume that once the son actually gets to college, there is no more inflation, just to keep things simple. So there will be 4 payments of 42,871 to be made. Somehow magically inflation ceases when the son enters college. You can do it for continuing with 10% inflation, but that will make it a bit more complicated, and you can try that as an exercise. So we just take the simpler case when there is 4 yearly payments of 42,871, and the amount of money which will pay for that, when that money is growing at 8% per year, which is the rate of return which James can obtain, that amount of money is, you'll find, will be 134,825. So this is actually the amount of money, therefore, James is going to need at the end of 8 years. And if this is the future value, then you can use now your calculator to calculate payments for this future value when the rate of return is 8% and the number of periods is 8. And that is going to give you that the payments are going to be 12,676. So 8 payments of this will lead to a future value of 134,825.